A little bit ago, I said I wanted a tiny computer that can fit into my pocket and be powerful enough so I can do everything that I need to do as a software engineer. Well, here it is. Okay, that'll definitely stretch out my pocket, but we're getting there. Now, for the last few months, we thought the Mac Mini M4 was the smallest, most powerful machine that's also inexpensive, unless you add a few options. Well, this is the new Geekom A6, and it's actually smaller, a lot smaller, lighter, less expensive, and Geekom calls this the best mini PC under 500 bucks. Notice they didn't say the most powerful because, well, it does have a pretty powerful Ryzen chip in it and pretty decent integrated graphics. And I've been doing a bunch of programming tasks on it, working very well, but I'm also curious how this thing will handle your machine learning tasks, your inference, local LLMs, something we've been doing lately more and more of. Now, we know the Mac Mini M4, this is the base model with 16 gigs of RAM on it. This can do pretty well, but it's limited to what size of model you can run based on the size of RAM. This machine comes with 32 gigs of RAM and 1 terabyte SSD out of the box, under 500 bucks. Now, of course, they are very different animals, Mac OS, Windows, and Linux, but a lot of software development tasks that I do these days are very much cross-platform, like developing JavaScript applications, developing mobile apps. LLM tools especially are being designed from the ground up to be cross-platform. So at this point, whether you were working with Mac OS or Windows or Linux, it's kind of a personal preference, but I just wanted to show you the ports that are available on these. Look at the difference in ports that you get with the A6. You get 2 HDMI outputs, a 2.5 gigabit Ethernet port, USB-A ports, 2 USB-C ports. Of course, only one of them operates at 40 gigabit, whereas on the Mac Mini we have 3. But the base model Ethernet port is only 1 gig. Now, what's nice about the Mac Mini is the internal power supply. This one does have an extra power supply that you need to connect, so that's an extra little bit of weight. I should probably count that. Overall, the Mac Mini does have more USB-C ports. It's all USB-C ports, whereas the Geekom A6 has a few USB-A and a few USB-C ports. But you know, the most important thing is that the Geekom's power button is on the front. All right, enough about that. Just kidding. Who cares if the power button is on the bottom? Because there's cases like this that have solved the problem for the Mac Mini. The power button is sticking out, but that's not what I really want to talk about today. Oh, I almost forgot. There's a full SD card on the side here on the A6. This is a really exciting little product because when I saw this at CES this year, I thought, this is crazy tiny. Not only is Geekom going to use this for the A6, this shell, this chassis, but they're also going to put a Snapdragon X Elite chip in here in a few months and an Intel-based chip as well. So there's going to be 3 machines that are exactly the same size and shape that are going to have different chips in it. So it'd be interesting to test those chips across those 3 devices. But for now, the A6 is the brand new one. My goal here is to find out if I can fit an entire mobile workstation in my pocket. To try out my dream of portability, I went to my secondary office, aka Starbucks. Not the most comfortable walk, but totally doable. You see what I go through for y'all? The compact mini PC pairs nicely with a compact 7-inch monitor and a super tiny foldable keyboard and trackpad combo. Of course, I pre-installed Visual Studio on this machine because I'm not crazy. I won't be installing it on Starbucks Wi-Fi, but for smaller programs like Git and VS Code, that wasn't an issue. The rest of the software, like benchmarking tools, I brought on my thumb drive. I do wish this machine had some USB-C ports on the front, but those are on the back and only USB-A on the front. But that's okay. I'll use one of my favorite flip-style USB drives here instead. Seriously, these thumb drives are the best. Not only are they fast, but they also flip. You need to get some of these. I'll link to them down below. Under the hood, we've got a Ryzen 7 6700H processor, integrated Radeon 680M graphics, plus 32 gigabytes of DDR5 RAM. There's also a 1 terabyte NVMe SSD inside. The M.2 NVMe drive is pretty quick. Of course, I'm kind of spoiled by the crazy speeds of my M4 Max MacBook Pro, but for everyday tasks and development work, this is perfectly fine. Actually, it's pretty fast, considering only a few years ago, the speeds were way lower than that. We're all spoiled now. Now, if you were to spec out a Mac Mini the same as the A6 with 32 gigs of RAM and 1 terabyte of storage, the price jumps up quite fast, $1,400 But of course, since we all know that Apple's 16 gigabytes is the same as 32 gigabytes on Windows, that's a little joke, a little reference, okay, anyway, you've probably heard it by now. if we get those same specs in there and drop the Mac Mini down to 16 gigabytes, the price is still more than twice of the A6. For Geekbench, we're looking at 2107 in single core and 10555 in multi-core. That's not bad for a mini PC you can tuck into your pocket. After I set up a Python environment, I stress tested the CPU with a Mandelbrot algorithm in Python. What I like about this test is it pushes all the cores to the max, and the A6 finished in about 53 seconds. Pretty respectable. Now, just for reference, the M4 Mac Mini ran the same test in 32 seconds. To really see how it handles for everyday dev tasks, I opened my usual .NET Blazor project in Visual Studio, and Node backend, an Angular frontend, and a bunch of Chrome tabs, no lag at all. The 32 gigabytes of RAM and the Ryzen 7 can handle a surprising amount of multitasking. Alright, I was having a lot of fun with this, but my eyes started hurting a bit, so I had to move on to part 2. And let me tell you, walking around like this is not super comfortable. Obviously not the most comfortable way to walk around with this stuffed in my pocket, but now the unofficial part of this video is a drop test. We'll see if this thing still works while doing our second part of this video, which is the AI testing. I do not recommend carrying all this stuff in your pockets. I'm gonna have to wait until we can shrink it down some more to really achieve my dream. Alright, now, is it possible that you can actually run AI models on this thing? Well, I've been doing a lot of testing of LLMs on this channel, different hardware configurations, and then I realized you have to have multiple models. So plenty of storage is important. This comes with a terabyte. And that way you can have your 1 billion parameter models, 3 billion parameter models, and up to 32 billion parameter models, all stored on here for different use cases. So if you're trying to write some code, the 1 billion parameter model is probably not the best choice for that. It'll give you something. If you ask it, I don't know, give me a JavaScript function for n factorial, it'll be probably fine for that. But something a little more complex, you're gonna need more parameters in your model, which is like 14 billion, 32 billion, or 70 billion. And you'll have those 1 billion parameter models on board, but don't discount the 1 and 3 billion parameter models, because they are also handy for things like, I don't know, writing emails or answering messages or recipes. Now, this is an AMD processor, so you might have heard that you can use something called ROCm to make your AI faster. And it used to be the case, but ROCm and the tools that run your LLMs have kind of parted ways, so you can still run older versions of Ollama and specialized versions of ROCm, but basically do not rely on that, and it's a giant pain to set up. LM Studio is a good tool for this, I'd say. If you don't know what that is, you can watch some of my older videos where I show you how to install it. Basically, you just go to lmstudio.ai, download it, and run it. That's it. Works on all your platforms. But here's where you gotta go to check out what you're actually running. If you go to this tab right here, the developer tab, and then LM runtimes, you have a couple of tabs on the left here. Model search. This is where you find and download your models. So grab a couple models. They're free. Amazing, right? What a world we live in. Grab whatever you want, but be careful here. So let's say you have this one, Qwen 2.5 7B, pretty good for coding. Qwen 2.5 Coder 14B, even better for coding. Check it out. This one is 8.99 gigabytes in size. Or if you just came out of college, you're gonna yell at me in the comments for saying 8.99 instead of 8.99. Either way, this model should fit into the RAM here just fine. Now, if you take a look at the 32 billion parameter models, now we're getting into a territory where you may or may not be able to fit that model into your VRAM here. VRAM is the RAM available for the GPU on this machine. Not a super powerful GPU, but it's an integrated GPU, so can't expect too much from it. There are some new AMD ones that just came out that are really powerful. Stay tuned on the channel. I might be testing one of those pretty soon. But check this out. Here you have the quantization. Right now, 32 billion parameters. Q2 means quantized to 2-bit. Really scrunched down quite a lot. It's 12.31 gigabytes in size. But if we select a different quantization that's not as quantized, like 4 or 8, or even 5 or 6, anything more than 2 basically, and it's going to be likely too large for this machine. It says it right there. Q4KM is pretty much the typical quantization. I'm making a separate video on quantizations, so stay tuned for that. I'll explain that in more detail in that video. Q4KM is pretty typical, and that one is 19.85 gigabytes in size. Definitely will not fit into the available RAM on this machine. So I've got a couple of them here, and we're going to test them out, but I want to also show you, besides model search, there's also the runtime tab here. And the runtime tab will show you that Vulkan is available and CPU is available. So both of these are two different ways of running the models on your devices. So we're stuck with CPU only or Vulkan. Well, Alex, what's the difference, you might say? Well, let's check it out. So I'm gonna load up a model here. I'm gonna say select model, and I like to manually choose the model load parameters. So I'm gonna flip the switch right here to on so I can manually choose that. And let's start with a small one like the Llama 3.2 1 billion instruct. If I click on that, you'll see that we have the GPU offload. So how much of this model is gonna be on the GPU? Well, let's take a look at 0 out of 16 layers. That's the number of layers. And I'm gonna say load model. Let's pop open our activity monitor, excuse me, task manager. Okay, now we see all our 16 cores. Look at those 16 beautiful logical processors. We also can monitor the GPU here. And let's say hello to us. Cool, it was pretty fast. It was loaded up in memory. It's only 1 billion parameter model, about 1 gigabyte in size. But you'll also see that this is actually in memory because we're not offloading anything to the GPU. So the GPU didn't do anything at that point. Everything was done on the CPU, and that's where that little spike is on the CPU. 37.48 tokens per second is pretty good. That's very fast. Now I'm gonna eject this model and I'm gonna reload it, but this time I'm gonna offload everything, all 16 layers to the GPU. Now we're gonna have this loaded into, take a look at the GPU here. We'll see that the dedicated GPU memory is where that is going to be stored now. So we have 4 gigabytes available here and 2.1 is being used. Now we're at 44 tokens per second, so quite a bit faster. Not a huge amount faster, but still 44. We're over that 40 hump, and we see that it was processed on the GPU. So even though we're not using GPU-specific AMD libraries, LM Studio is capable of tapping into Vulkan and utilizing the GPU in a generic way to run these models, which is super cool, and it helps us out quite a bit. But this is a very small model. What happens if we run a larger model? I'm gonna eject this one, and let's select this 7 billion, this DeepSeek R1 Distill Qwen 7 billion parameter model, and I'm going to offload. Now we have 28 layers instead of 16, so let's load that one up. Gonna take a little bit of time to load up, and this one is 7 billion parameter model, but it's also a larger file. It's 4.36 gigabyte file, which means it's larger than the dedicated GPU memory that's available to us, which is only 4. So that means that even if you select to offload all the layers to the GPU, you're not gonna be able to. The machine just won't. So we're using 3.1 out of 4 here. Let's say hi here. And of course, because this is a larger model, it's gonna be slower. So now we're getting 13.4 tokens per second. But remember, this is still better than what we would have gotten if we just ran on the CPU. There's that hump we have here. And let's have it write a longer story. You know what? Let's have it write a JavaScript function to, I don't know, trade stocks. So it's thinking now. It's a thinking model after all. And we'll see that while it's thinking, we're utilizing 97% of the GPU. You want to use as much of that GPU as possible for this. We'll see that compute 0 right here is almost all the way up. We're using a lot of that dedicated GPU memory, but a tiny bit of it is still going to the CPU. Not a big deal. So right here at this point, we're at 7 billion parameters. This is kind of about the threshold where we still see some advantage of GPU offload. But any models that are going to be larger than this, like the 14 billion or the 32 billion, they're still going to run, but now you're not going to have as much of an advantage whether you run it on a GPU or the CPU. Let's stop this and take a look. We're getting 12.74 tokens per second. Still pretty good. I mean, you saw this thing. It ran, it was going pretty fast. I show examples of how to do this on the channel, and members get extra videos as well. By the way, if you want to become a member, there's a join button right down below. You get extra videos and my thank yous. So let's go to the 32 billion instruct model, this Qwen Coder 32 billion, and we're going to try to offload 64 layers. Load model. Did it actually work? I'm hearing this device a little bit now. Here's some noise coming from it. Let's say hello. It's thinking. What's going on over here? We're getting 100% utilization from the GPU, almost 4 gigabytes of that dedicated GPU memory being used up. It is quite a bit slower. We're also seeing a huge spike in the system RAM as well. I can't believe it's actually running this 32 billion parameter model. Yeah, it's doing it. It's saying, hello, how can I assist you today? If you have any specific questions or needs, this is great. Now remember that this is the 2-bit quantized version. It's not going to give you the best quality results, but it's still working at 3.77 tokens per second. Pretty impressive. Here's another one. This one is bigger than can fit. It's this Qwen 2.5 32 billion instruct, but it's quantized down to 4. This is by Bartowski, who's a pretty prolific model quantizer. He's got a lot of models on Hugging Face. Does pretty good work. You should check out his models. We're gonna offload all 64 layers to the GPU and see what happens. Oh, failed to load the model. Model loading aborted due to insufficient system resources. But there is a little thing here that says model loading guardrails. LM Studio protects this machine from getting crashed. But what if we set that to a little bit more, let's see, relaxed? After all, this model is 19 gigabytes in size and our entire system has 32. So why can't we? Well, let's try it. I'm gonna relax the guardrails and see if we can load this up in here. Boom, failed. Let's turn off the guardrails altogether. I actually have never tried this before. Let's see what happens here. Load model. Doing something. Oh, look at that memory going up. Ooh, we're zigzagging. We don't want to zigzag. Oh, it's trying it again. It's trying it again. Come on, come on. Oh, did it work? Did it load? Wow, okay. So this is going to be all CPU, but let's see if this actually works. Hi. Whoa, I do not recommend you try this, but it's actually working. This is running a 32 billion parameter model, quantized down to 4 bits, pretty good quality, and I'm getting 2.4 tokens per second here on this tiny, tiny little machine. Now we are pushing the machine here quite hard. I'm gonna have it write a JavaScript function so we can take a look at the power draw. And I hope my machine didn't just crash. Whoa, what happened here? Something bad happened. This message contains no content. The AI has nothing to say. AMD software detected that a driver timeout has occurred on your system. So now the system actually kind of helped us out. Instead of crashing, it put us in this weird limbo. Probably not a stable system at this point. LM Studio unloaded the model. He's like, I don't think I want to deal with that one. Let's load a smaller model here because I want to show you the power draw. Like I said, not recommended. If you want to turn the guardrails back on, you can do it right here in settings, hardware, guardrails, and then, I don't know, let's put it on balanced. That sounds pretty good. And let's send a message. This way we can at least get something going, hopefully. Uh-oh, it's just not liking those big models at all, and my computer crashed. But the machine recovered itself. That's pretty incredible. Still, I do want to restart it just to be on the safe side, because once your machine becomes unstable like that, you never know what kind of things are happening with memory. Definitely not something this computer was designed to do, is to handle such incredibly large models. Just want to show you where the limit is, so you kind of know. But that was also how quickly it restarted. And let's get back into LM Studio here. We're gonna quickly load up a 7 billion parameter model and tell it to write a JS function. Boom. I said JAS function, but it understood that I'm running a JavaScript function. So we're getting 10 tokens per second here. Write it. I'm gonna force it to write it. Take a look at what power draw we're getting. So we're at 82, 84, 85 now. So we're between like 75 to 85 watts when this thing is running. Anyway, I'm really excited about this little machine. It's super compact and powerful. And I'm looking forward to Geekom's new machines coming out this year that have the same chassis but different chips in it. If you want to see those, I'll get those machines in here as soon as possible. Subscribe to the channel so you don't miss those videos. If you want to see a couple of other pieces of hardware tested for AI, I got a video here or here. Thanks for watching. I'll see you next time.